Hornets, welcome and thank you for joining me today. In this video, I'm going to be taking a look at how do we find arcs, specifically arc sine, arc cosine, and arc tangent. Now, I've noticed that as we were doing some of these, some people are still thinking that they have to get two answers. But you'll notice that whenever I see the word arc, or if I ever see a -1 exponent, I have an implied domain. An implied domain because the sign is only going to give me the first and the negative first quadrant, and it goes all the way to pi over 2 and negative pi over 2. So I cannot get an answer that is in the second quadrant. I cannot get an answer in the third quadrant. I can't get an answer in the fourth quadrant in the unit circle. This is important. Not only that, but if I have a negative, I have to remember that I'm going to be taking a look at the negative first quadrant. Once again, it's not going to be in the second, third, or fourth, and it won't even be in the first. It's going to be in the opposite of the first. And you have to keep in mind that picture. That's everything that we're talking about. So if I'm looking at negative root 3 over 2, I know that the sign of a positive root 3 over 2 is going to have to be pi over 3. But because it won't give me it won't do that, I'm going to have to call it negative pi over 3. That is the answer. The opposite of the reference angle in the negative first quadrant. Arc cosine won't give me a negative first quadrant. It goes in the first and the second quadrant from 0, pi, goes through at pi over 2 at 0, and then goes to pi. So it will give me an answer in the first and the second quadrant. So I'm not going to have a third quadrant or a fourth quadrant. Not at all. It won't happen. So if I'm looking at this cosine of -1/2, that's in the second quadrant. The reference angle is also pi over 6, and so my answer is in the second quadrant, pi over 3. So in the second quadrant, it's 2 pi over 3. That's my answer. There are not two. There is only one. Then when I talk about the arctangent is only in the first quadrant in the negative first quadrant, but unlike sine, it cannot include pi over 2 and negative pi over 2. Those are now asymptotes. And I'm looking at an answer in the first quadrant and in the negative first quadrant. So if I have a negative ratio, it's the negative first quadrant. So when is tangent going to be a positive root 3 in the first quadrant? Once I have that answer, I'm going to call it a negative. So I'm now going to say, where is it going to be at? I think that's pi over 3. Oh, so my answer has to be negative pi over 3. Look at the arc cosine of root 3 over 2. Well, we know that cosine is root 3 over 2 in the first quadrant, and it will end up being a pi over 6. That's my answer, pi over 6. Arc sine, positive. It has to be the positive first quadrant. Arc sine is 1/2, sine is 1/2 in the first quadrant at pi over 6. So my answer is pi over 6. Arctangent, positive. Positive first quadrant. When is tangent root 3 over 3? Pi over 6. Arc sine, negative root 2 over 2. It's going to give me a negative first quadrant. So when is sine root 2 over 2 in the first quadrant? Well, pi over 4. So my answer is negative pi over 4. Arc sine root 2 over 2. That's in the first quadrant. That's a positive pi over 4. Notice it's not going to give me a 3 pi over 4. It's not going to give me a 5 pi over 4. It's not going to give me a 7 pi over 4. Okay? Watch out. When is the arctangent 0? Well, that's at 0 pi. So my answer is 0 pi. If you wish to say 0, that's fine too. It's just simplified. When is the arc cosine -1? Well, we know it's got to be -1 right here at pi. Since pi is included, my answer is pi. And I move on. Now I've gone through and I made sure that I have several answers and several pages. So we're just going to do 4 more. When is arc sine going to be -1? Well, that's down here at negative pi over 2. Make sure we see that as a negative. So my answer is negative pi over 2. I'm not going to call it 3 pi over 2. Doesn't work that way. I can't get a 3 pi over 2. It can only be between 0 and pi over 2 or 0 and negative pi over 2. Arc cosine -√3 over 2. Well, we know arc cosine is positive √3 over 2 at pi over 6. We want it in the second quadrant because arc cosine only gives me the first and the second quadrant. So I'm now looking at pi over 6 in the second quadrant, and that would be 5 pi over 6. When is arctangent -√3 over 3? Well, we know tangent in the first quadrant is √3 over 3 at pi over 6. So this is negative pi over 6, between 0 and negative pi over 2. When is arc cosine a positive 1? Arc cosine is a positive 1 when cosine is positive 1. This only happens at 0 pi. This is how we work with our arcs. We have to remember, what is our implied domain? The implied domain for an arc sine is either between negative pi over 2 and 0 pi, or between 0 pi and pi over 2. When we see a negative ratio, we're negative. When we see a positive ratio, we're in quadrant 1. Arc cosine, the implied domain, is between 0 pi and pi. So if I have a positive ratio, it's going to be in quadrant 1. If I see a negative ratio, it's going to be in quadrant 2. I never use the third and fourth quadrant answers. I never use the negative quadrant 1 answer with an arc cosine. Arctangent. Arctangent's implied domain is now between, but not including, negative pi over 2 to pi over 2. As a result, I can clearly see that I'm either dealing with a positive 0 to pi over 2 or negative pi over 2 to 0. Once again, it cannot give me a second quadrant answer, a third quadrant answer, or even a fourth quadrant answer. They are outside of the implied domain. There you go. I hope this has helped. Please watch it again if you need it. Do some on your own and then check. There are a finite number of arc cosine, arc sine, arc tangents that we can do that involve exact values. Thank you very much, Hornets. I hope this has helped. If it has, please click like. If you have questions or concerns, or you have suggestions on how I can improve, please feel free to leave me a message. Thank you very much. Take care and good night.